Hello everyone, this is wrang. Today I'm going to give a presentation on my survey paper, which called Hadoop MapReduce Job Scheduling Algorithm Survey. This paper was published in 2016. So let's begin. The big data area is coming with more and more data are generated in many different areas, such as social networks, health cares, and sports, even in some auto cars. Uh, so how to deal with such huge data? It's really a, a hard problem. To solve this, many awesome frameworks has been developed. Among them, Hadoop is an efficient platform. For Hadoop, MapReduce plays a very important role because it's the uh, calculation or computation part for Hadoop. So to improve and optimize the performance of MapReduce, many algorithms have been proposed and implemented so far. In the next, I will give some basic information about Hadoop, and then let's discuss some basic algorithm about scheduling. So Hadoop is a Java open source framework uh, for distributed storage and processing on computer clusters with the very large data size. And Hadoop mainly consists two parts. Hadoop Distributed File System (HDFS), which is the storage part, and MapReduce is a processing part. In this picture, you can see the Hadoop framework architecture. On the left side is the workflow of MapReduce. On the left side, on the right side, sorry, on the right side is it shows the HDFS. Uh, so Let me talk about the left side first. The user machine just submit a query application to the cluster. We can see here we can use Hadoop to represent the cluster, and then the master node in Hadoop will assign this query to some different slave nodes. It is the slave node that finish the query application, and reduce process will regroup the data and assemble the result. And then the result of query will be sent back to the user. Hadoop. Uh, HDFS is used to storage uh, for large files in Hadoop. So to guarantee its reliability and rapid data accessing, replication of the data is used on different servers. Here means one the data will have 3 copies, and then and the different copy will be transferred or stored in different servers. HDFS consists of two types of nodes. One is called name node, the other is called data node. There is only one name node and several data nodes in HDFS. Name node is used for mapping of data blocks to data nodes and for file system operations management as open, close, and rename file and uh, directories. Data node is responsible for data blocks creation, deletion, and replication. Also, the name node used for maintaining the file system namespace to record file operations by the user. Uh, the, ma- uh, the MapReduce I think it will be much better with the graph to give some basic information about MapReduce. Here in the graph, we can see we have a map and reduce. Actually, map and reduce here means two different phases. Uh, uh, any job or any task will be finished in two different phases, map phase and reduce phase. As you can see, the input data will be uh, split into different small data sets, and each data set will be assigned to different mappers. We can say mapper, uh, map jobs, and after map finish is the job, not its computation. Some intermediate data will be generated and stored in a temporal location, and then the data will be pulled by reduce phase. It's in the reduce phase that the final result can be calculated, and then we have the results. Here we have a problem between map and the reduce phase. How to assign or schedule the intermediate data efficiently. So that's why I want to talk something about the scheduling methods. The first one is called the FIFO scheduler. FIFO scheduler, which means first in, first out. It is the basic and the default scheduling method in Hadoop. So it's very easy to be implemented, but this method reduces the data locality and unfair to smaller tasks. The second one is called the file scheduler. File scheduling assign averagely equal share of resources to applications. By default, the fairness is based on memory only, but it can be configured to work on both CPU and memory. So in case of single app running, or we can say application running, it uses the entire cluster. Free resources will be allocated to the new application, so a cluster can be shared between certain users. By default, fair scheduler lets all applications run, but it can limit the number of running applications per user with some parameters. So its advantages is fair and equal share resources allocation and short response time with small tasks. Because for the small task, it don't have to wait so long to be served. And this disadvantages is complex settings. To implement this method, we have so much parameter to be tuned. So that's why it's very hard to apply this method. And another drawback is unbalanced workload because of lacking job weight. The next one is called capacity scheduler. Capacity scheduler is developed to ensure the fair allocation of the computation resources between user and control job allocation based on physical machine resources. In this method, all the free resources can be shared between different queues or different users. It is the advantage. And as for the disadvantages is it's very complicated in implementation, and the higher capacity jobs will acquire the resources before lower priority jobs. So the the cluster capacity is shared between users, not between jobs, as we talked in fair schedulers. The fourth is called daily scheduler. Daily scheduler is widely used here. Delay means come from waiting for a particular amount of time for the data on the local node to be present. Otherwise, if the data is not available, we will skip this job and continue to to serve other jobs. The advantage is it solves the fair sharing a locality problem, and it simplify the scheduling and have no effect of uh, complex calculations. For its drawbacks or disadvantages is this method cannot work in all situations, and it's not fair in sharing of resources. Here we want to talk something about matchmaking scheduler. The matchmaking scheduler is implemented by finding matching between input data and the serial node. It just means we want to ensure or guarantee that the data and the program, the running program, are in the same node to save some RO or internet bandwidth. So the advantages here is it has a good data locality and utilization. We find the matched data quickly, and sometimes we have a very low response time. Uh, its advantage is also the disadvantages because sometimes we can't find the matched data in the same node. So that's why time spent in finding matched data will increase the response time. The latest scheduler means here later means longest approximate time to end. Uh, this scheduler is trying to make all tasks related to a certain job finished as soon as possible. Because if the job can be finished completely, uh, other jobs can be recorded or can be served. Uh, so it will increase the efficiency of scheduling. Um, as for the advantage is the method is very applicable to heterogeneity architecture or jobs. But due to lack of reliability, so we can't have a better performance with this scheduler. Another one is called the deadline constraint scheduler. Deadline scheduler is designed to try to meet the job deadlines and increasing the utilization of the system. Here in this method, the scheduler will compute the minimum number of map and reduce slots required for the job. So as in this procedure, it will cost other time and computations. That's why also it's very hard to find the execution time in cost. But once we can estimate this cost, uh, we can assign a specific time and resources to this kind of job. So that's why we see this method can aware is aware in timing and optimization. The next one is resource aware scheduler. Resource aware scheduler regards the resource availability for job scheduling, and the scheduler is based on the utilization and the contention of the resources on the machine. Also, it tries to minimize the consumption of these resources and increase the utilization. So for each node, we will have to make some configurations to indicate the disk outspeed and the actual processing power available or on each cluster machines, and some other modifications such as time slot and memory capacity. Um, for this method, the advantages is uh, the cluster resources used can be used with a good utilization rate, and it have a good effect in job execution. But we have uh, we have to pay a more resource monitoring and high-speed network. So we have so it's a trade-off between efficiency and more or extra works or more extra uh, calculations. Next is called HPC scheduler. HPC here means health priority, capacity, and availability. This method creates a queue of available nodes to accept new tasks, uh, and also gives a redundancy mechanism to overcome execution task failure. It considers the weight of the resource and the node to be selected based on its job success rate, priority of the jobs, and the default priority of the resources selected to execute the job, the capacity of the resources selected, and the availability of the resources. So the advantages is it has a good performance on the node with high hit rate, and it has a built-in redundancy mechanism. But the fast change in cluster state will increase overheading during execution. The last one is called round-robin scheduler. Round-robin scheduler is actually a modified version of FIFO. It tries to solve the problem of FIFO scheduler where job starts in order of submission, and this causes the later job this submitted job to start later. In round-robin scheduler, the latest submitted job will get a quick response and be started with a short delay. So this algorithm can minimize the average response time. Uh, so, another is it has a file sharing of the resource and simple to be implemented because this method is based on FIFO or methods, and the drawbacks is there's no priority among assignments and time delay in context switch. So about the conclusion is no universal scheduler that is suitable to all kinds of jobs, and the selection of appropriate method should according to the requirements of the user and the availability of resources. So it's meant about the survey papers. Any questions?